Myself Lakshmi Modakavi from BSc PASSM CBZ combination. My topic name is Structure and Specificity and Condition and Application of Organic Reagents such as dimethylglyoxime in inorganic analysis. First, we start a small introduction about DMG. The reagent should be specific or at least a selective in its action. The precipitate forms should be extremely insoluble. The precipitate should be a definite composition and stable on dying the inherent towards the atmospheric pressure. And the reagent should be soluble in water. Next, we see advantages of DMG. Both time and material are saved. Being a good solvent, they possess selectively in the dissolution of organic and inorganic substances. And next, we start about a DMG structure. DMG is an dioxamine of dimethylglyoxal key structure features. Two oxamine groups positioned the adjacent can form the bident chelate ligands through the two oxamine nitrogen atoms stabilizes the square planar complexion. Structure allows the extremely stable complex formation with a certain metal, especially nitrogen. Next, we see specificity of DMG. DMG is highly specific for Na2 plus under the alkyl condition. Na2 plus forms the square planar chelate very stable and insoluble. The complex is bright red crystalline and has extremely low soluble in water. Most other metals ions do not form the similar stable precipitate with the DMG. Selectivity is enhanced by slightly alkyl medium (pH equals 9-10), presence of ammonium hydroxide or ammonium buffer, masking agents for interforming ions, example citrate or mask Fe3+. Next, conditions of DMG. The critical conditions for using the dimethylglyoxamine as an organic reagent inorganic analysis. Primary involves the controlling pH, managing temperatures, using the alcoholic solution and employing the masking agents to prevent the interference. In conditions, there are some points. First one, the role of pH and optical range and acidic condition and alkaline condition. First, the role of pH. pH controls is paramount for the selective precipitation of metal ions, most notably nickel. And next, optical range. The bright red nickel dimethylglyoximate precipitation of nickel from qualitative in the solution buffered in the pH range of approximate 5 to 9 through same source indicates an optical range of 9 to 11. And next, acidic range. If the solution is too acidic, the DMG ligands becomes protonated, shifting the dissolved back into the soluble Na2 plus ions, thus preventing the complete precipitation. And next, alkyl condition. While the slightly alkyl condition is optimal, exclusively high pH can lead to the formation of soluble Na compounds or the precipitation of other metal oxidizes. And next, applications of DMG. The use of DMG extends beyond simple qualitative detection. There are qualitative analysis, gravimetric analysis, separation, photometric reagent, and industrial commercial uses. Dimethylglyoxime is concluded to be an extraordinarily sensitive and selective reagent for the qualitative detection and quantitative gravimetric determination of nickel. It achieves this by forming the highly stable, insoluble, bright red chelate complexes nickel in an ammonical solution.